First, we need to define what work is. Okay, this is chapter 5. Work is, take a look. It says it is the product of the component of a force along the direction of displacement and magnitude of the displacement. So maybe if I just read the definition like that, it's just too complex. But in the end, when you say the product is the multiplication, okay, it is the multiplication of the component of the force along the direction of the object. So if the object is moving horizontally, you're gonna get the force, the horizontal force component, okay? And you will multiply it with the magnitude of the displacement. In other words, work is the multiplication of the force, okay, or the component of the force that is going in the same direction as the object, and the distance that the object travels. So work is done on an object when a force causes a displacement. So this is a very important paragraph, okay? That's why it is included here in the presentation. Work is done on an object when, and just when the force causes that the object has a displacement. In other words, if I push so hard a wall, the wall is probably not going to move because I'm not strong enough. But it doesn't matter how much force I apply on the wall. If I don't move the wall, I'm not doing any work at all. I'm doing force. But if I'm not making the wall move, it's just not work, okay? So, work, it is mandatory that a force causes an object to move in order to have force. If no displacement is caused, then no work is done. The application of a force alone does not constitute work. For this reason, no work is done. Okay? This is the first important statement about work. And then it says, work is done only when components of a force are parallel to a displacement. In other words, you're going to consider just the force that goes along the direction of the object. If I'm moving an object horizontally on the floor, then the component that I will be using is going to be the horizontal component. But if I'm lifting an object, imagine I'm lifting a suitcase, okay? And that suitcase is like 20 kilograms. Then, if I'm able to lift the suitcase, I'm doing work. And because I'm lifting the object, the motion is vertical. So you will include only the vertical force that is acting on the object. So only the component of the force that is parallel to the object's displacement does work. And then we have the equation, okay? Here you have the SI unit that we're going to be using. The name of that unit is called joule, okay? And the formula is this one in the blue box that says work, W is for work, okay? Work net or net work is equal to the net force multiplied by displacement or distance, which also multiplies the cosine of the angle. The cosine of the angle. So take a look to this box over here. This D represents the distance that this box is going to move, okay? And a force is applied at a certain angle below the x-axis. So how do we get the work? Applying the formula. Multiplying the force, multiplying times the distance the object moves, and then cosine of the angle. Now take a look here. How is this box moving? Is this box, according to the force I'm applying, this force is moving horizontally or vertically?
Horizontally.
It's moving horizontally. So the parallel force that is parallel to the object's motion is going to be the horizontal component. Remember, when we have forces at a certain angle, we're going to have components. Okay, we're going to have a component in x, and we're going to have a component in y. Which of the two forces is actually doing the work, Fx or Fy?
X. Fy.
Fx. Okay, Fx is actually the force that is like pulling the box in this direction. If I just apply this force, the vertical component, if I just apply it, I won't be able to move the box because here you have a surface. Okay, it's like if you push a box down, it's not going to move. If someone sits on a box and you try to move the box, it's going to be even more difficult to move it because the vertical force in that case um, is causing the object to stay still, and if it is still, means no work is done. So it is important that we always make this analysis. What really is the force that is causing the object to move? Is that the vertical component? Is that the horizontal component? And you have to do that analysis. So take a look to this. It says important. If the force does not have an angle, we are just going to calculate work as this equation. Work equals force times distance. So forget about this box, okay? Forget about the forces that are acting on this box, okay? Forget about this force. Imagine that the only force that is acting on this object, así no era. Imagine that the only force that is acting on this object is this one, okay? And I say that this force is equal to 200 Newton. And I'm gonna move it at a distance. Forget about this distance, okay? Forget about this distance. Ay, no, así no era esta cosa. No. uh, Jesus Christ. Yeah, yeah. So, let's say that I apply this force and I move this box, okay? And this distance that I have here is 20 centimeters. Espérense. Okay? So, first of all, what you have to do is the analysis. Do I have an angle in this force? Is
Yes.
this force?
Yes.
Yes, I have an angle of 180 degrees. Okay, I know it. Okay, but all I'm trying to say is when you get the components of that force, it's not going to have a vertical component, right? Like if you have, for example, an angle different than that. If you see this force, for example, and I say that is the same 200. okay? But you know that because I have an angle here, this force also has components. But this one right here does not have components, just the
Yes.
horizontal component, okay? So when this happens, when this situation happens, all you have to do is apply the last formula that is shown right here. The one that says that work is just equal to force times distance. Now, be careful about the units. Remember, we measure distance in meters, not in centimeters. So, if you need to perform a conversion, the conversion must be done before you apply the formula. Okay? So, for this exercise, these centimeters should be converted to meters and then you apply the formula to get the work.
So how to see it?
And then the unit in which you measure the work is going to be in joules. Okay? So these 20 centimeters are going to turn into 0.2 meters when you convert. And the work is going to be 200 times 0.2. And that will give you 40 if I'm not mistaken. I better try it.
Yes.
Okay, that will be 40. And those 40 are going to be measured in joules, not Newton,
Which is
not
gonna be
Newton meters. It's going to be joules. And we represent joules with the letter J, uppercase J, like this. Beautiful.
when we have centimeters, always we need to pass it to meters.
Yes, if I give you feet, also convert to meters. Okay, always do the conversion because joules is an unit, it's a compound unit that is made of Newton times meters. And also you know that Newton is a compound unit that is kilograms times meters over second square. So actually a joule is going to be equal to kilogram times meter square over second square. These are the real units that are making up the work, that are making up 1 joule. But if you write these units, that's okay. But it's better, easier to write just joules, okay? So remember, to have joules, you need meters to be included. If you use another different unit, then you can no longer have joules. That's why I totally recommend to do the conversion before, okay? So this is um, this is the first part of the presentation about work, okay? So right now with the thing, this thing with the whiteboard, we're gonna try with some examples. So it says, how much work is done on a vacuum cleaner pulled 3 meters by a force of 50 Newton at an angle of 30 degrees above the horizontal? So first of all, we need to write the givens. Writing the givens is very important, okay? So the problem is actually given as, well, the problem is about a vacuum, okay? Someone is cleaning with a vacuum, okay? And when you use the vacuum, you're actually pulling it or pushing it. It depends. It depends on how you clean. It depends on your habits. So, but this vacuum is being pulled by a force. So the force is given and it's 50 Newton. The unit is okay. Forces are given in Newton. But then it says the distance it is pulled. It says 3 meters. So distance or displacement is going to be 3 meters. And then it says at an angle of 30 above the horizontal, 30 degrees. Okay? So you can do a sketch or you can just apply the formula. That is up to you. Okay? Um, So for me, it's gonna be like something like this. Bueno, brazos tan raros. Wait. Okay, like that. So this person is pulling. Pulling force is going to be exerted more or less in this direction. Okay, this is going to be the force, and you are going to have an angle that is specified in the problem. Now, the distance or the displacement that this is going to have is 3 meters. This is the information that you can put in the problem. Or you can just draw the vector of the force, say that this is 50 Newton, say that this is the angle of 30 degrees, okay? And that will be just fine. And also include the displacement of 3 meters. Everything that you want to include will be just fine. Or I'm a simple person, which is going just to apply the formula for work. And I say that work is easier if we get it like this. Force times distance times cosine of the angle. This is the main equation. We substitute by the givens and we say work is equal to 50 Newton times a distance of 3 meters multiplied times the cosine of 30 degrees. How much is this?
129.9.
129.90 joules.
Okay, 129.9 joules. You can write 130, that will be okay. I prefer that you write the decimals. And remember, the units that we obtain when we multiply newtons and meters is joule, okay? Very simple. Ahí está. That was it. Can you believe that? No, right? It must be fake. How is this even possible? Now, this is a topic that everyone likes until ah, now I'm going to mess it up. No, I'm joking. This one is also easy. But you need to be careful about something. So let me show you. I'm showing you two examples here. Take a look. In the first example, the motion that the vacuum has, of course, is a horizontal motion. So the force that we are actually included in this exercise is the horizontal component of the force. I mean, if you get the horizontal component of the force and you multiply times the distance, you will also get this answer. But take a look to this example, the one of the suitcase. And I use the same example when I mention it. Well, I need 20 kilograms also. No, can be the other side. Well, it says a 20 kilogram suitcase is raised 3 meters above a platform by a conveyor belt. How much work is done on the suitcase? Now this one is interesting. What do we need to get work? I'm going to write the equation again, the formula. Work is equal to force times distance times the cosine of the angle. That's the formula. Now let's write the givens. In the givens, the problem is telling me extra information, of course, because it's giving me that the suitcase is 20 kilograms. Why do I need the 20 kilograms? Para nada, they are just messing with my mind. Let's see if we can use it later, okay? I'm going to write it because it's given. Mass is 20 kilograms. It says is raised 3 meters above a platform. Is raised 3 meters, that means that is a distance, okay? The suitcase is lifted a distance of 3 meters. So because this is a distance, we can say that displacement of the object is 3 meters from the ground to a platform that is 3 meters above. Then it says how much work is done on the suitcase. They're asking me to find work and they're not giving me an angle. O sea, we cannot solve it because the angle is not given. Let's make a sketch, okay? Let's make a sketch that maybe it help us to do a better job. Remember what I said in the presentation. It says when no angle is given, okay, then we need to calculate work as force times distance. So that means that
And
because
also, we don't have work.
exactly, we're not gonna get it, but it has a reason. I mean, it doesn't mean that if it's not mentioned, it's always gonna be like that. It has something to do, okay? So, but yes, this is a situation where it needs to happen. Now, I'm going to sketch the problem. I'm going to sketch the suitcase is beautiful, okay? To make it more realistic. You see it, and that's a suitcase, okay? Even better. Now, this suitcase is 20 kilograms. And, okay, this is the ground. Well, and it says that it's lifted a distance of 3 meters, okay? And here above, I'm going to have like the platform. I really don't need to, okay? I really don't need to. But if I need to sketch something, it will be something like this. So the distance between the, I mean, the actual position of the suitcase and the platform, I know that it is 3 meters. Okay, so this is the situation. So what happens? I mean, what is the force that is acting on the suitcase?
On first, the gravity.
The gravity. So when you lift an object, what you say is, ah, qué pesado. And it is heavy because of gravity. Gravity is the acceleration that is causing the objects to go down, but also the mass of the object. So there is a force, there is a force that is always pushing down the objects, and this force is what we know as weight. Weight is an example of a force, okay? So take a look. The problem is not giving me any force at all. It's just giving me a mass. But you know that if you have the mass, you can get the weight, okay? So this exercise actually you can say that work is equal to the weight of the suitcase times the distance. Now, if you lift this object, you, I mean, if you lift this object, you have no angle, right? Just a 90 degrees angle. That means that it doesn't have a horizontal component. So that's why when I told you that when no angle is mentioned, you're going to use the entire force, okay? Not the component because no angle is mentioned. So this work in the end is going to be equal to the weight of the suitcase. That is 20 kilograms times gravity. Remember that weight is equal to mass times gravity, okay? So mass times gravity times the distance that the suitcase is lifted, that is 3 meters. How much is this?
188.6.
188.6.
Okay, in what units do we measure the work?
Joules.
Joules. So even though here it's you can see there are like hundreds of units, okay? But remember, the weight is a force that is measuring newtons. So in the end, you are multiplying newtons times meters, which is going to give you joules in total. And that will be the answer. So, no, si no era, espérense. So in conclusion, with these two kind of exercises, when you have the angle, you're going to use this formula, okay? And you're going to include all the data available to apply the formula. When objects are lifted, the force that is acting on the object is actually the weight, okay? And if the objects are completely vertically lifted, no angle is gonna be given. So you can totally ignore the rest of the formula like we did in here. So in the end, the weight of this object is gonna be just, the work on this object is going to be its weight multiplied times the distance it is lifted. Now, the chapter work and energy is not called work and energy because energy is not part of it. It is part of it, okay? But as you can see, we're gonna have two kinds of energy that will be included. One of them is kinetic energy and the other one is potential energy. When you read the word kinetic, what is the first thought that goes to your mind?
Movement.
Movement.
Friction.
Yeah, it could be.
It can be friction.
Any other thing that goes to your mind?
Motion.
Motion. Okay, kinetic energy is the energy due motion. So speed is going to be included. Now, potential energy is going to be the energy according to an object's position from the ground. Example, I am standing on the ground, so I have no potential energy because I'm exactly on the ground. My distance from the ground is 0, so I don't have potential energy. But if I go to the third floor in a building, then I will have potential energy. Now, let's take a look. Uh, Kinetic energy is the energy due to object's motion, and that is the formula. Very nice formula. And take a look. The unit that we're going to be using for energy is the same that we use for work. That's why the two topics are related. Work and energy are related. They're being measured in the same units. But the formula is different. Take a look. Ke stands for kinetic energy, and the formula is 1/2 or 0.5 mass times the speed that the object has raised to the second power. So that will be the energy of an object that is related to the motion. And then we have potential energy. We have two kinds, gravitational and elastic. Gravitational is like the example that I was giving you, according to the position that I have. And elastic potential energy, it is the energy available when objects or elastic objects, the energy that those elastic objects use to come again to its original configuration, and those are the two equations that will be used. These equations, we're going to apply them next class, okay? But I wanted to give you the introduction of it. The two are energy, and the two of them are going to be measured also in joules. If you have doubts on chemistry homework, get in the meeting after this class is over, okay? So I can help you out.